Volcanoes, how often do they erupt and what happens when they do? Share on Facebook, share on Twitter, print, mail, other share options. ABC Science by Anna Sala. Updated the 22nd of November 2017 at 10:13 a.m. First posted the 22nd of November 2017 at 9:22 a.m. Eruption of Mount Sakurajima. Lightning can form in volcanic ash clouds by ash fragments colliding to produce static electricity. Getty Images, Mike Lyvers. Planet Earth is covered in hundreds of volcanoes, many of which will be erupting at any one time. Many of us only notice volcanoes when they are about to explode or disrupt our travel plans, but these spectacular forces of nature can have a significant impact on people living in the local area. While volcanoes can be destructive, they are also responsible for creating rich agricultural soil, minerals like gold and silver, diamonds, hot springs, and geothermal energy. So how do these iconic wonders form, and what risks do they really pose? What is a volcano? A volcano is like a chimney that allows hot liquid rock, called magma, to flow from a layer within the earth and erupt onto the surface. The magma can come from as far down as 200 kilometers in the mantle, and once it erupts, at a piping hot 700 to 1200 degrees Celsius, it is called lava. As magma rises through many kilometers to the Earth's surface, dissolved gases contained within it form expanding bubbles. These bubbles increase the pressure of the magma and, if this pressure is great enough, the volcano will erupt. The amount, temperature and composition of magma, including the amount of trapped gas contained in it, determines the type of volcano formed. The three most common large types of volcanoes are strato, shield and caldera. Stratovolcanoes. Illustration of a subduction volcano. Anatomy of a stratovolcano such as Mount Agung in Bali. ABC, Julie Ramsden. Stratovolcanoes are cone-shaped mountains that have been built up from layers of ash and lava. They are generally the tallest type of volcano and are known for their violent explosions. Bubbles of gas build up in the magma, which has a high silica content, and explode, creating volcanic ash, consisting of tiny gritty sharp fragments of glassy snapped frozen magma and rock from the sides of the volcano vent. Examples of stratovolcanoes include Agung in Bali, Yasur in Vanuatu, Etna in Italy and Fuji in Japan. Shield volcanoes. This flatter type of volcano is named after the Roman centurion shield shape of the volcano, made by repeated gentle flows of lava down its slopes. Shield volcanoes have magma with a relatively low silica content. The magma is very hot and runny, so they are less likely to build up and create explosions, although they still can. There are many shield volcanoes in Hawaii and Iceland, including Kilauea and Eyjafjallajökull. Manaro volcano on Ambi Island on Vanuatu is also a shield volcano. Aerial shot of Mount Kilauea. Mount Kilauea in Hawaii is a shield volcano, supplied, USGS. Caldera volcanoes. This type of volcano has the coolest and stickiest magma. It tends to erupt so violently its top collapses and leaves a large basin shape in its place. The collapse leads to widespread fallout of ash and other hazards. Some caldera volcanoes are up to 90 kilometers across and are called supervolcanoes. Examples of supervolcanoes are Yellowstone in the US and Lake Toba in Indonesia. Where are volcanoes found? Volcanoes are found all over the world, but the most common location for active volcanoes is at the boundaries of tectonic plates, where plates are converging. One plate pushes under another, a process known as subduction, and as it sinks it melts and generates an explosive type of magma that is vented through volcanoes on the upper plate. These kinds of volcanoes are common along the so-called Ring of Fire, a horseshoe-shaped area around the Pacific Ocean. Volcanoes also occur in the middle of oceans where tectonic plates are pulling apart or diverging. This mainly occurs underwater, where it can also lead to hydrothermal vents on the deep sea floor that harbor extreme forms of life. Volcanic activity in Iceland also comes from diverging tectonic plates. Hawaii's Big Island, as seen from the International Space Station. Hawaii's Big Island is the largest active above-ground volcano on Earth, supplied, NASA, ESA, Samantha Cristoforetti. Some volcanoes occur in the middle of tectonic plates, and are created as the plate moves over a hot part of the Earth's interior. As the plate continues to move across the hot spot, a chain of volcanoes, like those seen in the islands of Hawaii, are created. The Big Island is the biggest active above-ground volcano on Earth, around 180 kilometers wide by 9 kilometers high. How often do volcanoes erupt? Some small volcanoes only erupt once in their lives, while other volcanoes erupt multiple times. Kilauea volcano in Hawaii, which has been erupting continuously since 1983, is the world's most active volcano. While some volcanoes erupt at regular intervals, there are always exceptions to the rule. And even volcanoes that haven't erupted for more than 10,000 years, traditionally thought to have been extinct, can start up again, says volcanologist Ray Saws, an emeritus professor at Monash University. Grand Prismatic Spring, Yellowstone National Park is this sleeping giant waking up. Hot springs at Yellowstone National Park suggest the volcano may be preparing for an eruption. Wikimedia Commons, Frank Kowalczyk, for example, Professor Saws says recent evidence suggests the Yellowstone supervolcano appears to have a major eruption every 700,000 years, with the last being just that, 700,000 years ago. It is now showing signs of stirring. It's in the category of perhaps being due for another one, Professor Saws says. Can we predict when an eruption will happen? Predicting when eruptions are going to occur and whether there will be an explosion or just a lava flow can be very tricky. There's a high degree of unpredictability, because nature and magma don't follow black and white rules, Professor Saws says. While quakes tell us magma is moving, that does not mean it will get to the surface. It's possible it will cool and solidify before it erupts. Residents observe Mount Agging from a viewing point. Mount Agging, uncertainty around whether a volcano will erupt can be nerve-wracking. AP, for Dialisnawati, the major hurdle for scientists in predicting eruptions is they don't have any way of remotely sensing the characteristics of magma that determines how it will behave. Every country in the world with active volcanoes monitors their activity and shares the information globally. Such monitoring and alert warnings for volcanic eruptions are based on assessing clues such as timing. If a volcano has erupted at reasonably regular intervals, then this could help suggest when it might erupt again. The longer the period between eruptions and the larger the last eruption, the bigger the predicted eruption. And even if a volcano behaves as expected, not a given, a recent inventory suggests we can only use this method on around 1,200 of the 3,500 active volcanoes around the world, for which there is an eruption history. Earthquake activity. Increased earthquake activity can indicate a volcano is about to erupt, but not always. Change of volcano shape. When magma rises, it can cause measurable changes to the summit and slopes of the volcano. Warming water. As magma rises, it can also cause detectable heating of groundwater and surface lakes. Gas emissions. Changes in the amount and composition of gas emitted from volcanoes can tell scientists about how magma is moving. What happens when a volcano erupts? Play 3.2 megabytes GIF. Flowing hot lava can incinerate, bulldoze and bury things in its path. Flowing hot lava can incinerate, bury and bulldoze things in its path, but at least is usually moving slowly enough for humans to get out of its way. But when a volcano explodes, things get a lot more spectacular and risky. For a start, there's hot gas and rock, called pyroclastic flows or surges, that tumble down the slopes. This is what buried the city of Pompeii when Mount Vesuvius erupted in 79 AD. Then there are volcanic bombs made of rock that can fly out of the vent, and an eruption cloud made of ash and gas that shoots up into the air. Exploding volcanoes also lead to mudslides, called lahars, and tsunami. Earthquakes, landslides and flooding from volcanoes melting surrounding glaciers are some events associated with eruption. What are the health effects? A tenth of the world's population lives within the potential footprint of volcanoes, with more than 800 million people living within 100 kilometers of active volcanoes. According to recent research analyzing fatalities from volcanic activity between 1500 and 2017, about 540 people a year are killed by volcanic activity. Most of these people were killed within a 10 kilometers radius, but deaths still occur up to 170 kilometers away. Ballistics or volcanic bombs are the biggest immediate danger. Pyroclastic flows and fast-moving avalanches of hot rock, ash, and gas are the most dominant threat between 5 and 15 kilometers from the volcano. Fine falling ash can cause respiratory problems, as can the gases released during explosions, in particular carbon dioxide and sulfur dioxide, Professor Saws says. Carbon dioxide is potentially the most dangerous volcanic gas because it's dense, so it settles and stays near the ground, and secondly you can't smell it, he says. What about the environment? Eyjafjallajökull volcano clouds of volcanic ash and gas can create havoc with our health, environment and travel. Wikimedia Commons, Arne Frioriksen. Sulfur dioxide also contributes to acid rain, and volcanic emissions also affect the weather and climate. While carbon dioxide has a warming effect, the main effect of the volcanic emissions is a cooling effect, Dr. Saws says. This is because of ash and sulfur dioxide reacting with water vapor in the air, leading to the albedo effect, or reflection of the sun's heat. Professor Saws says this is especially the case with supervolcanoes, whose major eruptions release in the order of 40 to 1,000 cubic kilometers of molten rock. The very fine ash and gas gets lifted into the upper atmosphere, circumnavigates the globe and begins to affect the climate, he says. And travel. Flying into volcanic ash clouds can also be a major hazard for air travel. Aircraft engines are so hot they melt the ash back into fragments of magma that clog up the exit vents. Aircraft carry radar that detect volcanic ash clouds, and advisory centers around the world use satellites to track the ash clouds and provide warnings to planes. Engines on the ground can also be affected by volcanic ash.